Welcome to SAP Tech YouTube channel. Today we will discuss SAP background job troubleshooting and work process administration. You know, if you've ever seen a mission-critical SAP system just grind to a halt and felt that pressure to fix it, like right now, then this explainer is going to give you the exact playbook you need.
Okay, let's just dive right in. In a real-time SAP environment, seeing your CPU utilization hit 99%, well, that's a huge red flag. It's basically the system screaming for help. This means it's under extreme stress, and for your users, that translates to one thing: agonizing slowness. This isn't just some number on a screen, it's a critical performance bottleneck that we, as Basis consultants, have to solve, and fast.
So, imagine this. You get that call. The system is completely unusable. What's your very first move? This is such a classic scenario, something you'll face on any project. We're going to walk through the exact troubleshooting playbook, starting with the most likely culprits to get that system back up and running.
So here's our game plan for today. First, we'll pinpoint the symptoms of a system under stress. Then, we'll get to know the core components, the jobs and work processes. After that, we're getting hands-on, solving a live high CPU crisis. And once we've put out that fire, we're going to put on our detective hats and investigate a mysterious failed job. And then finally, we'll wrap it all up into a powerful troubleshooting playbook you can use.
You know, the very first thing any Basis consultant is going to check during a performance issue are the big three: CPU, memory, and disk. In our situation, the CPU is totally maxed out. And when we look a little closer, we see the top offenders are these disk plus work processes. Basically, these are the fundamental SAP processes that do all the work for users. The fact that they're eating up all the CPU, well, that's our first major clue. It points us directly at SAP's core operations.
Since those display work processes are our problem, we really need to understand the engine they're a part of. And that leads us right to SAP background jobs and work processes. I mean, these are the backbone of all the automated tasks in the system. They run everything from payroll to big data jobs, but when they go wrong, they can cause exactly the kind of performance nightmare we're seeing right now.
So, what even is a background job? Well, think of it like a scheduled task that the system just runs on its own, automatically. No one even needs to be logged in. They're absolutely essential for all the heavy lifting. But here's the catch. If a long-running or just badly designed job gets stuck, or way too many of them run at once, they can literally suck up every last bit of your system's resources.
Every single job goes through a life cycle. It starts as scheduled, then it gets released when it's ready to go. While it's running, it's active, and hopefully it ends up finished, but sometimes it gets canceled. Now, for our troubleshooting mission, the two statuses we really care about are active and canceled. They tell us what's burning down the house right now and what already failed. If you like this video, please subscribe to SAP Tech channel. Your one click inspires us to create more such videos.
All right, enough theory. Let's get practical, right? We're now going to log right into the SAP system and hunt down the exact processes that are causing that crazy 99% CPU spike. This is where the real investigation starts.
Our first stop is transaction code SM37. This is the job overview screen. As a Basis consultant, this T-code is basically your command center for anything and everything related to background jobs. In a real-time project, if there's a fire related to a job, this is where you go to find the smoke.
Okay, so here in SM37, the very first thing we do is filter for only active jobs. And boom, the result, as you can see on the screen, is immediate and it's very revealing. We've got a flood of identical test jobs all running the same program, RS memory. I mean, seeing dozens of the exact same job running at the same time, that is a massive red flag. It's a classic sign of a runaway process. Our immediate job is to select all of them and just cancel them to stop the bleeding.
And this brings up a super critical point, something a lot of beginners miss. It's not enough to just cancel the running jobs. If it's a repeating job, you have to find the parent job that's creating all these copies. You have to go in and change its status from released back to scheduled. Seriously, if you skip this step, the problem's just going to pop right back up in a few minutes and you'll be right back where you started. Don't forget to subscribe if you're finding this practical walkthrough helpful.
And here it is. The proof is in the pudding. Just look at the immediate impact of that simple action. The CPU utilization just plummeted from a critical 99% all the way down to a super healthy 30%. That is a huge, immediate win, and it just goes to show how quickly you can stabilize a system once you find that root cause.
Okay, so we put out the fire, but what about solving a mystery? Our next scenario is a bit different. A critical job has failed.
Its status is canceled, but nobody actually canceled it manually. This needs a more systematic, almost forensic approach to figure out what really went wrong.
For this kind of investigation, we've got a standard toolkit. We always start with the job log in SM37. If that doesn't give us what we need, we go looking for short dumps in ST22, which are really just detailed crash reports that SAP generates when a program fails. No dump? Then we scan the main system log in SM21. And if we're still coming up empty, we go to our ultimate source of truth, the work process trace file.
So, we start back in good old SM37. We find our canceled job, and we open up its log. And right there, the log gives us our first clue. Internal session terminated with runtime error. Now this isn't just an error message, it's basically a direct instruction. The system is telling us it generated a detailed crash report, a short dump, and that our next stop should be transaction ST22 to go read it.
So we head over to ST22 to look for that dump, and we'll check SM21 for system logs right around the time the job failed. But, sometimes you just hit a dead end. In real-time environments, those dumps might have been cleaned up by a routine job, or the system log just might not show anything useful. It's a really common situation, and it just means we have to dig even deeper.
When those high-level logs don't give you the answer, the work process trace file becomes your final destination. This is the most detailed, granular log of exactly what a work process was doing, step by tiny step. And it's often where you find that smoking gun.
Now, before we can find the trace, we have to know where to look. We use SM50 to see the work processes on just a single application server. But we use SM66 to see all the processes across all the servers at once, a global view. And thankfully, in the SM37 job details, the system tells us exactly which server and which work process number our failed job ran on. That's our target.
Here are the exact steps to get to that trace file. From the job details in SM37, you just note the execution server and the work process number. Then you pop over to SM50, select that specific work process, and you navigate through the menu you see on the screen. Administration, then trace, then display file. And that takes you right into the raw, detailed log file of everything that process did. Your subscription truly motivates us to create more deep dive content like this.
And there it is. Buried deep in that trace file, we find our smoking gun. The log explicitly says, found an open lock, and a dict access error. This tells us exactly why the job failed. It was trying to access a database object, but another process had it locked up. The system couldn't wait forever, so it just terminated the job. This is the level of detail that solves the really tough cases.
So we've now solved two very different but very common real-world problems. Let's take everything we've learned and distill it into a clear, repeatable methodology that you can use every single time you face a job-related issue.
So here's the crucial takeaway. For a system on fire with high CPU, you go straight to SM37, find those runaway active jobs, cancel them, and, this is the most important part, find the parent job and set it back to scheduled. For a mysterious failed job, you follow the forensic path. Start with the job log, then check for dumps, then the system log, and finally, dive into the work process trace. That trace file is your ultimate source of truth.
Everything we've done has been reactive, fixing problems after they've already happened. But that leads to our final question for you to think about. Now that you know how to find the root cause, what steps would you take to proactively monitor your SAP system and catch these issues before they ever impact your users?
Please check the detailed information in description of this video. And if you enjoyed this video, don't forget to subscribe to the SAP Tech YouTube channel.